right, so we're going to talk about difference of squares, which is the last type of factoring we need to talk about. We did common factoring, we did trinomials, now we're doing difference of squares. So what you'll notice about difference of squares is this type of factoring is only for binomials, two terms. There also has to be subtraction. That's why it's called difference. The last thing is the first term and the last term have to be squares, perfect squares, so that means like x squared, 9, which is the same as 3 times 3, any examples like that. The other weird ones are like y to the power of 4, it's the same as like y squared times y squared, same idea. So, before we get into like how it works, let's try and think of it like a trinomial, okay? If I had x squared minus 25, and I needed to write it as a trinomial, the x squared's here, the minus 25's here, what's in the middle? How can I make it so that this is the same as this? Well, it'd have to be like 0x, right? Because then we're adding nothing. So if we think of it like a trinomial, I need to make 25, negative 25. The factors are 1 and 25, 5 and 5, okay? And one needs to be plus and minus. So if we did negative 5 and positive 5, those add up to 0, which is what we want. So really, this turns into x minus 5, x plus 5. If we rainbow this out and distribute it, it would be x squared minus 5x plus 5x minus 25, which again simplifies to what we want. So the rule that we're trying to see, if you have a binomial, where's the difference? All you do, actually I wrote over here, if you have something squared minus something squared, all you do is the a values go at the front and the b values go at the end. One's plus, one's minus. So if we zoom out so we can look at that first example, it was x squared, so we know we have to do x times x. And it was negative 9, so we know we have to do 3 and 3. One needs to be plus, one needs to be negative. The order of the plus and minus don't really matter. And hopefully you remember this from the polynomials unit. This is one of the special factors that if you have this kind of binomial times binomial, it turns back into this kind of special form. But whatever. This is one of the types you need to memorize, and you need to identify if you see it. So when I see something I need to factor, the first thing I say is there common factoring? So in this example, there isn't. Then I say, is it a trinomial? And this is not, so I don't need to worry about those two. Then I go, is it a binomial? And this is binomial. Then I need to say, is it negative? And this one is. And the last thing I need to say is it squared? So 100 is a square. X squared is a square. 49 is a square. Y squared is a square. And P squared is a square. Everything's a square, so it's good. That means we can do difference of squares. So I'm just going to write this. 100 squared, square rooted is 10, so 10 times 10. X squared is x times x. Don't forget, sometimes there's numbers and variables. For the second term, I got 49, so that's going to turn into 7 and 7. And then y squared is going to be y and y. And then p squared is going to be p and p. Last thing, plus, minus. If I wanted, I could check. I would distribute it out to check to find the answer, but I know it's right. Difference of squares is actually one of the easiest types of factoring. Once you identify that it's a difference of squares, you just follow the steps and write this. And that's it.